All right, let's look at an example of a 3D approach to a problem. So we're going to look at this scenario. Somebody tells you for $10 you can roll a single die repeatedly for as long as you want. If you ever get more than 7 of the same number in sequence, you win 1,000. If you ever get roll more than 11 of the same number, you get 1,000,000. So for example, if you could roll and roll and roll and then you end up with, say, 5, 5, 5, 5, 5, 5, 5, then you'd win 1,000. If you could somehow end up with 11 of the same number, then you would get 1,000,000. So how are we going to answer the question, is this a good bet? What's actually going on here? So we need a question that you can answer with a computer. So when we say define the question, we mean define something in terms of something we would actually solve with a machine. Remember, a computer is just a tool, and you have to solve problems using this tool. So you're the one who solves the problem. It's not the computer that solves the problem. So how should you use this tool to address this problem? How many tasks will you need to do? What's a good name for the problem? So we're going to call this the longest constant subsequence problem. So if a single die is rolled a large number n times, what can we expect to be the longest subsequence of consecutive rolls of the same number? So here's our main question. We're going to have a list of numbers, n of these, where n is going to be very large. And each number is either 1, 2, 3, 4, 5, or 6. And we want to find the longest constant subsequence in that list. So, now that we've talked about defining the problem, let's talk about the number of tasks in defining this problem. So we're going to have to simulate dice rolls. We're going to have to generate this very long list, and then we're going to have something that actually finds the longest constant subsequence. So now we can design. So we have our tasks. We're going to simulate dice rolls and have a longest constant subsequence. We're going to have a list of integers to begin with for the longest constant subsequence, and we're going to have a length of the list for the simulated dice rolls. So now we need to think algorithmically. What's our goal? What's our initial state? Where are we starting? Where do we want to end up? And in progressing from the beginning to the end, we need to go step by step. So the question we'll always have is, what is our next step? So to simulate dice rolls, we just need to append random integers between 1 and 7 to a list. So the only design requirement here is we need to look up whatever the Python command is for generating random numbers. And for that, we're just going to type in the word random and the dot, and it will tell us how to find random numbers. The longest constant subsequence, we're going to design using an example. Now we don't want to use a trivial example. So special cases, trivial examples can be used as tests, but they shouldn't be used as design tools. And then we want to think in terms of a loop table. So here are our thoughts. The current length starts out at a 1, and because 1, when we do the first entry, is the longest constant subsequence. Then we move to the 2, and 1, 2 is not constant, so we still have our longest one is only length 1, but then 2, 2 is a constant, so now we have a subsequence of length 2. And so our current length is 2, and the longest we have is also 2. 2, 2, 3 is not constant, so then we're going to set our current length back to 1 and start looking again for a constant subsequence. Our longest is still 2. 3, 2 is not constant. 2, 5 is not constant. But 5, 5 is constant, and so now we have a subsequence of length 2. We move to the next one. Now we have a subsequence of length 3. Now we have a subsequence of length 4. You can see it right here. 1, 2, 3, 4. And Now we start over. The current length is 1 because the next entry is a 4, not a 5, but our longest to date has a length of 4. 4 is constant. So 441 is not constant. Our longest is still 4, and there's our answer. So when we design, we need to think about what are the inputs, what are the outputs, what's the flow, what roles do the variables play, what roles do the tasks play, what kind of loops and branches are we going to be using. And so a flow of information comes from looking at, say, a loop table. So this is just in a table form what we've already looked at. Let me mention that some people use flowcharts. This would be a flowchart for our flow of information. And this is the way it's typically written. Decisions are the diamonds, and loops are simply indicated by arrows repeating until a decision kicks you out of a loop. Here's pseudocode. So if we were just going to write it down without worrying about what language it's in, it would look something like this. And there it is in Python. And Python, of course, was intended to look like pseudocode, so this is not a surprise for us. So debugging. There's always going to be errors. Now, one thing that you'll learn as you gain experience is that each person tends to make the same types of errors over and over and over. So if you're a bad speller, then it may be that when you make errors, most of the time your errors are spelling. So we can categorize the types of errors we make. Languages and compilers often provide tools. So notice also there's a difference between debugging and testing. Debugging means you're just getting it to work. Tests means you're determining the domain of the function, the inputs for which it works properly. And then benchmarking is when we measure performance. So here's some types of errors. And again, remember, you'll probably make one type of error more often than others. And so you'll actually get to where you know what kind of errors you make when you make errors. Here's the final implementation for the simulate dice rolls. All we need is to know that we can generate random integers using randint, which comes by simply looking at the methods attached to the random command. Our final implementation is we simulate dice rolls, and then we have the longest constant subsequence, and you can see we're updating the current length and then using the current length to update the longest. So that's the only task we want to do with that. And now we can test it out.